In recent years, the advent of 3D printing technology has revolutionized many industries, and the automotive sector is no exception. Car enthusiasts and professionals alike are now leveraging 3D printing to create custom parts, reduce manufacturing costs, and accelerate the prototyping process. This video delves into the fascinating world of 3D printing car parts, explaining the process and what you need to get started. Understanding 3D printing technology. 3D printing, also known as additive manufacturing, involves creating three-dimensional objects from a digital file. The process builds the object layer by layer, using materials such as plastics, metals, or composites. This method offers remarkable precision and the ability to produce complex geometries that traditional manufacturing techniques might struggle with. In the automotive world, 3D printing is used to make everything from small components, like brackets and clips, to larger parts like bumpers and body panels. The technology behind 3D printing is continually evolving, offering new possibilities for the automotive industry. Initially used for prototyping, it now plays a critical role in producing functional end-use parts. This evolution is driven by advancements in materials, printing methods, and the growing demand for customized automotive solutions. As a result, 3D printing is not only transforming how parts are made, but also redefining the design and engineering processes in the automotive sector. The process of 3D printing car parts. The journey of 3D printing car parts begins with designing the part using computer-aided design software. This digital model is essential as it dictates the exact dimensions and specifications of the part to be printed. Once the design is finalized, the file is converted into a format compatible with the 3D printer, typically stereolithography or object. The printer then reads this file and begins the printing process, layer by layer, until the part is complete. Different types of 3D printers are used depending on the material and precision required. For instance, fused deposition modeling printers are common for plastic parts, while selective laser sintering or direct metal laser sintering are used for metal components. Each type of printer has its unique advantages and limitations. Fused deposition modeling printers are generally more affordable and suitable for a wide range of applications, making them popular among hobbyists and small businesses. On the other hand, selective laser sintering and direct metal laser sintering printers offer higher precision and are better suited for complex, high-performance parts. Post-processing may include cleaning, curing, or finishing the printed part to ensure it meets the necessary standards and aesthetics. For example, plastic parts might require sanding, painting, or coating to enhance their appearance and durability. Metal parts often undergo heat treatment or machining to achieve the desired mechanical properties and surface finish. This post-processing stage is crucial for ensuring that the printed parts are not only functional, but also aesthetically pleasing and ready for installation. Materials and printers you need. Choosing the right material is crucial for the success of your 3D printed car parts. Common materials include acrylonitrile butadiene, styrene, and polylactic acid for plastic parts, known for their durability and ease of printing. Acrylonitrile butadiene styrene is particularly popular in the automotive industry due to its strength, flexibility, and resistance to high temperatures. Direct metal laser sintering, on the other hand, is biodegradable and more environmentally friendly, making it a preferred choice for non-critical components. For more robust applications, materials like nylon, carbon fiber-infused plastics, and various metal powders, aluminum, titanium are preferred. Nylon offers excellent strength, flexibility, and wear resistance, making it suitable for parts subjected to mechanical stress. Carbon fiber-infused plastics provide high strength-to-weight ratios, ideal for performance-oriented components. Metal powders enable the production of durable, high-performance parts with complex geometries that are difficult to achieve with traditional manufacturing methods. Advantages of 3D printing car parts. One of the significant advantages of 3D printing is the ability to quickly prototype and iterate designs. This rapid prototyping can significantly reduce the time and cost involved in developing new car parts. Traditional manufacturing methods often require expensive molds and tooling, which can take weeks or even months to produce. In contrast, 3D printing allows designers to create and test multiple iterations of a part in a matter of days, accelerating the development process and enabling faster time to market. Additionally, 3D printing allows for customization, enabling car enthusiasts to create bespoke components tailored to their specific needs and preferences. Whether it's a unique body panel, a custom dashboard, or a personalized shift knob, 3D printing makes it possible to produce one-of-a-kind parts that reflect the owner's personality and style. This level of customization is particularly valuable in the aftermarket and restoration segments, where finding replacement parts for older or rare vehicles can be challenging. 3D printing also reduces waste, as the additive process only uses material where necessary, unlike traditional subtractive methods that can leave behind excess material. This not only makes 3D printing more environmentally friendly, but also more cost-effective, as it minimizes material consumption and reduces the need for extensive post-processing. Furthermore, the ability to produce parts on demand eliminates the need for large inventories, reducing storage costs and the risk of obsolete stock. Challenges and considerations. While 3D printing offers many benefits, it is not without its challenges. The initial investment in a quality 3D printer and materials can be significant. High-end printers and advanced materials are often expensive, making it difficult for hobbyists and small businesses to justify the upfront costs. Additionally, the printing process can be time-consuming, particularly for larger parts or those requiring high precision. Depending on the complexity of the part and the material used, printing can take several hours or even days. Post-processing can also be labor-intensive, requiring skills and tools that not every hobbyist might possess. Cleaning, sanding, painting, and assembling the printed parts can add to the overall production time and cost. Ensuring the structural integrity and reliability of 3D printed parts is another critical consideration. While 3D printing technology has advanced significantly, printed parts may still exhibit weaknesses or defects that need to be addressed through design optimization, material selection, and post-processing techniques. Moreover, 3D printing is not always suitable for every type of car part. High-stress components, such as engine parts or suspension components, may require the strength and durability of traditionally manufactured parts. Understanding the limitations of 3D printing and selecting the appropriate applications is essential for achieving the desired results. Collaborating with experienced designers and engineers can help overcome these challenges and maximize the benefits of 3D printing in automotive manufacturing. Future of 3D printing in automotive manufacturing. The future of 3D printing in the automotive industry looks promising. As technology advances, we can expect even greater precision, faster printing times, and more diverse material options. Researchers and manufacturers are continually exploring new materials such as high-performance polymers, advanced composites, and bio-based materials to expand the capabilities of 3D printing. These innovations will enable the production of lighter, stronger, and more sustainable parts, further enhancing the appeal of 3D printing in automotive applications. Automakers are already exploring 3D printing for mass production of parts, potentially transforming how cars are manufactured and maintained. For example, companies like BMW and Ford are investing in large-scale 3D printing facilities to produce complex components more efficiently and cost-effectively. This shift towards additive manufacturing is expected to reduce lead times, lower production costs, and increase design flexibility, enabling automakers to respond more quickly to market demands and consumer preferences. This technology also opens up possibilities for on-demand part production, reducing the need for large inventories and enabling more sustainable manufacturing practices. Instead of maintaining extensive stockpiles of spare parts, manufacturers can produce parts as needed, minimizing waste and reducing the environmental impact of automotive production. Additionally, 3D printing can facilitate localized manufacturing, allowing automakers to produce parts closer to their customers and reduce transportation costs and emissions. That's all for today's video. Don't forget to give us a thumbs up and make sure to hit that subscribe button and ring the bell icon so you never miss out on our latest videos.